Guys, how you doing? This is Coach Scott with Purple Wave Chemistry, and we're going to be talking about electron configurations here in Unit 2. So what are these things? Well, we're going to start talking about some orbital diagrams. These are how the electrons line up in an atom. So we use orbital diagrams to give us a nice little shorthand way to illustrate or to show us the energy levels of these electrons. Now, each one of these boxes represents one orbital. Now, orbitals are always on the same shell. They're drawn together. So if you got p orbitals, they're on there with the other three p orbitals. Arrows represent the electrons. Now, the direction of the arrow shows where there's a positive or negative spin. Okay, so how do we do the energy? Right, and I've got some of these made up for you. I'll give you copies. Right, so we can draw these vertically or horizontally. I like the vertical ones. All right, but you need to know first how many electrons the atom has. So again, if we have a neutral atoms, the number of electrons is going to equal the number of protons, which is the same as the atomic number for a neutral atom. So let's just there. All right, so we have three rules for filling these electronic orbitals. Number one, the off-bow principle. That tells us that the electrons are always added one at a time, and they always go to the lowest energy orbital first until all the electrons have been accounted for on that level. Then it can go up. There's the Pauli exclusion principle. This says that the electron can only have a maximum of 2 electrons. And if they're in that same orbital, then they must have an opposite spin. One must be up, one must be down. Hund's rule. If 2 or more orbitals of equal energy are available, then the electrons will go to their own orbital first before they show up in pairs. Those are our 3 rules. So off-bow, that's why I like this little illustration. So off-bow is a German word, means building up. Now, Bohr and Pauli developed this in 1920, and they state that the electrons will fill the lowest energy level orbitals first. So think about it like, if you're staying in a hotel and the elevators don't work real well, you're going to try to be in the bottom floor first, right? You're going to go from the bottom floor to the upper floor because you don't want to walk up the stairs. Right, I like that. So the Pauli exclusion principle, okay, you can only have no more than 2 electrons in this, can have the same quantum numbers. And if they are in the same orbital, one has to be up, one has to be down. They have to have opposite spins. So this is atomic number 5. There's 5 electrons. Boron. Yes. So they got the 1s orbital field up and down, the 2s orbital field, and 1p orbital field. That's great. We wouldn't write it like this. All right, that 2s orbital, they're both got the same spin. That's wrong. Don't do that. I like this. This is good. Hund's rule. So we're all boys school. We can definitely understand this. So think about it. If you're sitting in the bathroom at the urinal line, right? There's certain rules, right, guys? You're not going to go right there. If you're the only one there and somebody else comes in, they're going to go further down the urinal. This is what we do. Now, if these little rules, every other urinal is filled, then this fella, he'll have to take it, this one right here, and he does. And if somebody else comes in, they will take that one. So anyway, you're only going to occupy one subshell, if you can, before you double up on a orbital. So every orbital in the subshell is singly occupied first. All right, empty seat rule You're not going to sit next to each other on a school bus until all the seats are taken up. Yeah, I like the urinal thing better. All right, so if we've got carbon, 1s2, 2s2, 2p2. So carbon will have, there are two electrons not together, but on different suborbitals. So let's talk about this. How would we feel the energy level for magnesium? Magnesium is 10, 12. So how would we do it? Up and down here, and I'm just going to grab this one and move it out. We do like that. One up, one down on 1s2. One up, one down. There's 4 electrons. Again, we have 12 to fill. We've got a total of 4. One up, one down. One up, one down. One up, one down. That's 10. And of course, the 3s is filled. Pretty cool, huh? So, yeah, we got a couple of these. We'll work on these in class. And just remember to follow those 3 rules and you'll be good. Now let's talk about electron configurations. We talked about orbital diagrams. Well, what if we don't have an orbital all the time diagram? So we have to write these out so people can understand it. So this is a electron configuration. So each component of this tells us something. The number in front of the subshell gives us the level or the N, right? So that's our N. The second letter, all right, tells us what the top of subshell or the shape is. That's a P. The first number gave us the level. That's a 4th level, energy level, all right? Now the superscript, that's going to tell us how many electrons are in those subshells or in those orbitals, all right? So this tells me that there are 5 electrons in the 4p orbitals. All right. One's by itself. So here's our orbital filling diagram, or electron configuration, or whatever you want to call it. Oh, here's our electron configuration. We just write these guys out. So if you need to, do this a little bit, then write this out. So I've got 2 in the 1s. I got 2 in the 2s here on sodium. I've got the 2 P's. I got 6 of them. Then I got the 3s, 1 in the 3s. So there's my electron configuration. There's my orbital diagrams. All right, so let's look at sodium. All right, the ground state configuration. That means all the electrons are as low as they can on the off-bow diagram. So sodium, there are 11 electrons because it's neutral, and 11 protons. I ain't worried about the protons. I'm worried about the neutrons, or the electrons rather. So I've got 11, so I'm going to fill them up. There's 2, 4, 10, 11. I've accounted for 11 electrons. So that would be the ground state configuration. All right. Ooh, let's look at this one. This is krypton. All right. So there's the electron configuration. Okay. The electron configuration, and there's the orbital diagram. I could draw this out first if I need to. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. That tells me it's 4p6. 4p6. Now write these in the correct order. That's why I like you guys using these for the time being. All right? That's the ground state configuration. All the electrons are in their lowest level. So we'll practice some of these in class. Or you can work on them now if you want to. Think about it. You can, yeah, that's fine. All right, so we did all that. Now let's talk about excited states. Remember the first part of the unit, we talked about an electron getting excited, right? And going to a higher energy level. Same thing here with the quantum model. So let's say we've got a sodium atom and they get excited, all right? It had an electron in the 3s level. So let's say it's got just enough energy to go to the 3p, all right? And then as it falls back down, it's going to emit that yellow light, as it goes back down to its ground state. Now, which of these would be the correct if we had a magnesium 2+ ion? All right, so magnesium has got a electron number or atomic number of 12. So it's Mg2+. All right, so if it was 12 electrons, so I've lost 2 electrons. All right, so that means I have 10 electrons. So all I've got to do is count this out to make sure which one gives me 10 electrons. So that's 1s2, there's 2, that's correct, in the correct order. All right, 2, 4, 6, that's 10. So that would be C. All right, there's chlorine, 1-. That means it's got an extra electron. Chlorine is 17. Yep, chlorine is 17. So it has 18 electrons. Count them out. 1s2, there's 4, 10. 2 and 3p6, that is 18. So that would be the answer. All right, guys, we'll work with some of these in class. Oh, here's an excited state of sodium. So again, that's a ground state. There's 11. So what happened? Ooh, can't be 2p7. Can only have 6 of the 2 p's. Ooh, it got excited from 3s to 3p. It's probably going to be C. And it is. I don't know. All right, guys. Unit 2 is done. Get ready for Unit 3. Life is grand. Coach Scott saying, Hullabaloo, Kanick, Kanick.